We are often told that the history of physics is a series of triumphant eureka moments. Newton's apple, Einstein's clock towers, the discovery of the Higgs boson. We celebrate the hits, but what if I told you that the most important work happening in physics right now, the achievement that defines our understanding of the universe more than anything else, is actually a history of failures? Imagine spending 40 years building a cathedral only to prove that the ground beneath it can't support it. In the world of theoretical physics, we've spent decades building beautiful, complex, alternative universes, theories like supersymmetry and string theory, and one by one, we are watching them crumble. This isn't a disaster, it's the most underappreciated achievement in the history of science. To understand why ruling things out is a victory, we first have to look at what we actually know. For the last century, humanity has achieved something miraculous. We have actually made sense of the universe at a fundamental level. We have the standard model of particle physics, a mathematical masterpiece that describes every particle and every force we've ever touched. And we have general relativity, Einstein's grand vision of space and time as a flexible fabric. These two pillars are the most successful theories in history. They have passed every test we've thrown at them with flying colors. But here is the catch. They're incomplete. They don't explain dark matter. They don't explain dark energy. They don't tell us why there's more matter than antimatter, or why the constants of nature have the specific values they do. We know there's a deeper truth hidden behind the curtain, but every time we try to peek behind it, we find nothing. Because the standard model and relativity don't explain everything, theorists did what they do best. They dreamed. They gave us supersymmetry, the idea that every particle has a shadow twin. They gave us grand unified theories, suggesting that at high enough energies, all forces become one. They gave us technicolor and extra dimensions. For decades, these weren't just fringe ideas, they were the mainstream. They were considered so mathematically beautiful that they had to be true. Thousands of the world's most brilliant minds devoted their entire careers to these extensions. They expected the Large Hadron Collider to find S particles. They expected our detectors to find WIMPs, weakly interacting massive particles. But as the data poured in, the beautiful theories began to die. One by one, the experiments came back empty-handed. This is where the public, and even some scientists, get it wrong. They call this a crisis in physics. They call it a waste of billions of dollars. But they are missing the point. The hallmark of a great scientific idea isn't just that it could be true, it's that it can be tested. By exploring these failed paths, we have performed the most massive process of elimination in human history. Every time a detector fails to find a specific type of dark matter, the universe is telling us, not there, try again. Every time the LHC fails to find a supersymmetric particle, the universe says, wrong direction, look deeper. This negative progress is a monumental achievement. We have successfully ruled out thousands of ways the universe could have worked, leaving us with a much smaller, much more precious set of possibilities. We aren't failing, we are narrowing the search for the absolute truth. And the stakes couldn't be higher. While we are busy ruling out the wrong theories, the mysteries are piling up. We are facing the Hubble tension, where different ways of measuring the expansion of the universe give us different answers. We are looking at neutrino masses that shouldn't exist according to our old rules. We are standing on the edge of a revolution, but we can only cross that threshold because of the underappreciated work of the skeptics and the data crunchers. They are the ones doing the hard labor of constraining reality. They are the ones who refuse to be blinded by beauty and insist on truth. Progress in physics isn't just about the aha moment when a new particle appears. It's about the quiet, disciplined courage to say, we were wrong about this, and now we are one step closer to being right. So the next time you hear that physics is stuck or that we haven't found anything new in decades, remember this: we have found plenty. We have found the boundaries of reality. We have mapped the no-go zones of the cosmos. The most underappreciated achievement in theoretical physics isn't a new equation, it's the relentless, data-driven destruction of our own biases. We are stripping away the illusions of what we want the universe to be, so that finally we can see it for what it actually is. The truth is out there, and thanks to the science of ruling things out, it has nowhere left to hide.
Subscribe my channel for future videos. Thank you.